AP Cram, Calculus AB, Free Response Exam Review, Question 50, Speed, Magnitude not direction, Absolute Value. A particle moves along a straight line. For t is between 0 and 5. The velocity of the particle is given by v of t is equivalent to -2 plus t squared plus 3t to the 6/5 power minus t to the third. And the position of the particle is given by s of t. It is known that s of 0 is equivalent to 10. Find all values of t in the interval between t is less than or equal, greater than or equivalent to 2, or less than equivalent to 4, for which the speed of the particle is 2. I'm just going to assume that these numbers represent minutes, although we're not told specifically what they are, just for more clarity, okay? So, this particular solution is slightly intuitive and would involve your calculator unless you're some type of genius that can solve this really quickly in under 5 minutes by hand. But I don't recommend doing that just for time's sakes, even if you're capable of doing it. So I'll give you a moment to think. All right, so in this particular instance, to come up with the solution, you have to kind of get out of your mathematical brain and get into your tactical, analytical brain. And so we're asked to find values of t on the closed interval. T is between 2 and 4, including the endpoints 2 and 4. And we're asked to determine where the speed of the particle is 2. Okay, you need to distinguish between speed and velocity. This is where you need to understand the definition of a scalar quantity and a vector quantity. Scalar quantities just consider the magnitude, such as 2. Vector quantities consider magnitude and direction, such as +2, -2, negative denoting one direction, usually towards the west, and positive denoting another direction, usually towards the east, okay? But here we're asked for speed. Speed is a scalar, not a vector, so we don't have to consider the direction. That means it could be either -2, +2, in any old direction. We just want to know where is the speed to, and we don't care about the direction, okay? All right, so what we basically have to find is this. We have to solve for the absolute value of v of t is equivalent to 2. And that's, again, because speed is a scalar quantity, so we're not concerned about the sign associated with 2. We just want to know where is the magnitude 2. And not only do we need to determine where the magnitude is 2, we want to know where the magnitude is 2 only on the closed interval between 2 and 4 for this equation, okay? So now is not the time to go ahead and solve this equation. What you're simply going to do is input this into the graphing function on your calculator, and you're basically setting 2 equivalent to v of t, but we're solving for the absolute value of v of t. And don't solve for the absolute value of 2. It's not the same function. It's similar, but not exactly the same, okay? All right, so when you graph this function, you're going to get something that looks like this. Here goes the line 2, all right? And here goes, and this monstrous thing here is your v of t function. And we can see that there are 5 points of intersection. So 1, 2, 3, 4, 5, 6, actually 6, where this function holds true. But remember, we're isolating the closed interval between 2 and 4. So essentially, we'll only be concerned with these 2 points right here. And if you were to isolate, okay, I just want to show you that the blue line, this is a dark blue, represents 2. And then the purple line represents the function v of t, which is t to the third, t squared, plus 3t raised to the 6/5 power plus 2. Okay? All right. Well, the absolute value of it. Okay, so now if you were to isolate a number line, these points here represents these points over here, excluding this point, but we're only concerned with anything from 2 up until 4, which is not written in because we didn't need to go that extreme. And we see that we have 2 points where v of t is equivalent to 2. And if you trace these points on your graphing calculator, you'll find out that the first is equivalent to 3.12763, and the second is equivalent to t equals 3.4734. All right, so this is the most efficient and strategic way to go about this. Please trust me on this. Don't go about it any other way, because if you do, you'll just end up with a really long solution where you have to find several roots. And that's smart. It's brainy. It demonstrates your ability to solve, but that's not really what's required in this instance. All right?